This video is going to cover Unit 29, Section 3, Computing Heights and Bases of Regular Pyramids and Right Circular Cones. Okay, so we know from before that the volume of a cone or a pyramid is the base, area of the base times the height divided by 3. So if we were given the volume and maybe the area of the base, then we could find the height. So we would algebraically solve this for that. So that would be multiply 3 out and divide the area of the base. So it would be 3 times the volume divided by the area of the base is equal to the height. Now, if you had a situation where you were given the volume and the height and you needed to find the area of the base, you could do the same thing. So, let's see. 3 times volume divided by the height would be the area of the base. So these are the 3 equations that we can use to find any one of the dimensions that we need. Now, with a cone, if we wanted to find, so I've got a situation like this. I've got the volume of this cone right here is 52 1/3 inches cubed. The height is 10 inches. I'm looking for the radius. Now the radius is in the area of the base. Remember, the area of the base is equal to pi r squared. So what I need would be this one right here. So the equation would be 3 times the volume divided by the height is equal to pi r squared. But this is what I'm looking for right here. So I would multiply by 1 over pi, or divide by pi, it's the same thing. So over here I would have 3 times the volume divided by h times pi would equal the radius squared. But I want the radius, not the radius squared. So I would take the square root of both sides, and my final equation would be r is equal to 3 times the volume divided by the height times pi, and all of that underneath the square root. So that would find the radius for me. So I just need to plug those numbers in. So radius is equal to 3 times the volume, 52 1/3, divided by the height, which is 10, times 3.14. So this is, you can just put this in your calculator as 52.3333 and carry it like 3 or 4 threes, and that would probably be good. Or if you know how to use mixed numbers on your calculator, you could do that too. Or you could turn it into an improper fraction. Let's see, 3 times, I'm going to turn it into a mixed number. Or keep it a mixed number. No, not that way. 3 times 52.333. That'll work. And then 10 times that is 31.4. And then I got that, and now that's almost 5. So I'm going to round that to 5, and then I'm going to take the square root of it, because I haven't taken the square root of it yet. So that's raising it to the 0.5. Square root of 5. So the radius is equal to the square root of 5, which is the same thing as 2.24. So that is the radius of that right there. Ta-da! It's a short section, but I picked, I think, what would be one of the hardest things to solve for, which would be the radius, because you have to take the square root of stuff. So once again, we're using the basic formula, which is right here, and we're solving it for the radius, but in order to do that first, we have to solve it for the area of the base, because the radius is in the area. And once we do that, we've got it right here, just like that. So the area of the base for a cone is pi times r squared. So I multiply by 1 over pi. Then I've got r squared times that, and I have to take the square root of both sides. And there's my equation for the radius. Then I just plug the numbers in. Sometimes people will plug the numbers in first. I like to keep the variables in there and then solve the equation with the variables in it. And then once I've got my equation solved for what I want, which was radius in this case, then I go ahead and I put the numbers. Well, 3 is a constant. Then I just put the numbers in where they go. But you don't have to do it that way. You can go ahead and put the numbers in and then manipulate them. It doesn't really matter, as long as you're comfortable doing it either way. Okay, let's take a look at page 723. Let's take a look at just a couple of these problems here. Number 7 looks good. So it says, compute the height of a pyramid with a base area. So I'm going to write these down as I go. So a base area of 32 feet squared and a volume of 152 cubic feet cube. Now, these units are the same, so when I do this, I'm going to find the height, and it's going to be in feet. All right, so the one equation that we have is height is equal to 3 times the volume divided by the base area. So height is equal to 3 times 152 divided by 32. Okay, fraction bar, 3 times 152, 32 in the denominator, 14.25. So the height is equal to 14.25 inches. Awesome. Now, one that looks really good is number, I think it's 14. 14 is using figure 29-10 at the bottom of page 723. Okay. All right, so the tank is shown in the figure. It's a cone. It has a dipstick to measure the level of water in the tank by measuring the vertical height. So that means the dipstick's going straight up and down in the cone. The cone holds 10,000 liters, so that's the max that it will hold, 10,000 liters. And its height, its overall height is 100 centimeters. Okay, so if the water is at 50 centimeters in height, what is the radius of the cone that holds that water level? Okay. Ooh, this seems kind of complicated. This is not as difficult as it seems. Okay? So, the first thing that we have to do is we have to do some conversions here. We have the volume is in the units of liters. You have to be very careful with units when you're dealing with math. The units have to line up or it doesn't mean anything. I can't use the volume of 10,000 in the equation because that's liters. It won't mean anything. So I have to convert 10,000 liters to cubic centimeters. Well, remember from the last lesson, 1 centimeter cubed is equal to 1 milliliter. All right, that's just what it is. 1 cubic centimeter is 1 milliliter. Used completely interchangeably. Now, 10,000 liters, and I want to change that into milliliters, which would be cubic centimeters. So let me do something here. Let me do some times. And I'm going to put liter in the bottom here, and then milliliters in the top. I can also basically just put cubic centimeters there too. From before, remember that there are 1,000 milliliters in 1 liter. Okay? So liters in the bottom here and the top here, so they're going to cancel. And the only unit that I'm left with is milliliters. So 1,000 times 10,000. So I am going to have the volume is going to equal 10 million centimeters cubed. Now I have the units all lined up. Okay? So what I'm going to do is I need to find, there's more than one way to do this, but for right now, because we don't have any trig at this moment, when we study trig, we'll have another way to do this, which I think is a little bit simpler. But what I need to do is I need to find the radius of the cone at the maximum point, at the biggest point. So that would be, I can't see that. It's too small print. R something on the figure. The biggest radius when it's full. Because I know that volume and I know that height. Because what I'm looking for, remember, is I want to put that equation right up here. I'm looking for the base area is going to be equal to 3 times the volume divided by the height. I do not know the volume at 50 centimeters. And I don't know the radius. So I can't calculate that. It's not just as simple as cutting this number in half. Okay? So what I'm going to do is I'm going to say the base area we know to be pi r squared is equal to 3 times the volume divided by height. I need to multiply by 1 over pi. So r squared is equal to 3 times the volume divided by pi times the height. So the radius is equal to the square root of 3 times the volume divided by pi times the height. So that's going to be the radius. Now I have all of these numbers. I just need to put them in. So 3, 10 million divided by 3.14 times the height of 100. I could have just said 314 right there. So this is going to give me, then I'm going to, I guess I could take the square root of it all at the same time. I usually would just find that and then raise it to the half power to take the square root. So the square root of 30, 30 million divided by 314 equals, that's really close to 310. I am going to round that to 310 because it's very close. And since I've rounded pi down, I'm going to round this up. Kind of a little bit of back and forth. Okay, so that means that the radius, I'll draw it this way. What I'm doing right now is I'm just looking at the side of the cone. Okay, so this distance from here to here, let me draw it out, is 100 centimeters from there to there. The distance from here to here, I just figured out was 3, oops, put a 2. Boy, I do that a lot. 310. That's a right triangle. Now, what I want to know is what is this radius right here at 50, when the height is 50. So we did some proportions. So let's say that 310 over 100 is the same as the radius that we're looking for over 50. So I have radius and height and height. Now, if I had trig, what I could do is I could use this number and this number, and I could find that angle, and then I could bounce it back and find that side right there. But we haven't studied trig yet, so that's fine. Now, there is another way you can do this, but this is the simplest way. So I cross multiply, and I get 100 times r is equal to 50 times 310. Divide that by 100. So I just put that in my calculator. Fraction bar, 50 times 310 divided by 100. Oh, I get that radius is equal to 155. Right there. Now, Why this problem works in this section is because we had to find first this radius right here. So we used this height, the overall volume, and then we found the radius using this equation right here, and then put our numbers in. Once I found out what that radius is, I can just look at it as two similar triangles. These are similar triangles because they're both going to share this angle. This side and this side are parallel. So that means that's a 90-degree angle right there too. And this angle and this angle would be the same as well. Based on parallel lines, way back, remember parallel lines intersected by a transversal. These are corresponding angles, so they're going to be the same. So based on knowing that this angle is used for both triangles, so therefore it has to be the same, and then this angle is going to be the same as well. You can also say that because these are both 90 degrees and this angle works for both the small triangle and the big one, then this angle and this angle have to be the same based on 180 minus both of those. So that's another way to look at it. And then once we have this proportion of 310 over 100 is equal to R over 50, then we cross multiply and we find R.